From the Science History Institute, I'm Alexis Pedrick, and this is Distillations. All season, we've been talking about the hopes, but also the fears of genetic engineering.
They don't even know what's going to eventually come out of this experimentation. It could be anything. It could be contamination, infections, something that could crawl out of the laboratory, such as a Frankenstein.
I am convinced that when the people of the community understand the unbelievably unknown nature of the dangers, tampering with millions of years of evolution, they'll say no.
From the beginning, people have been anxious about the unintended consequences of genetic engineering, but they've also been worried about people using it in intentionally harmful ways. This is a public comment from a recombinant DNA summit in 1977.
Well, one thing about technology and science today is whatever can be done is usually going to be done. And just because some scientists say that they don't want to create a new race of Superman, as Adolf Hitler did, doesn't mean that it's not going to happen.
At the time, many people dismissed this comment. The concern was so hypothetical. The science itself was still so far off. Why bother talking about it? But there was reason to worry. This is Matthew Cobb, the author of As Gods, A Moral History of the Genetic Age.
I mean, people immediately become interested in seeing, is there any limit to the kind of cell that we can manipulate? And the biomedical community starts to think about, well, can we use this to change human genes?
3 decades after that public comment, something new was about to enter the genetic engineering toolbox, and it would bring us a lot closer to those 1977 eugenics fears.
I remember reading the article when it came out in 2008 in Science, and I went, okay, bacteria have an immune system, that's weird, and then turned the page. And this is why I'm neither a millionaire nor a Nobel Prize winner, because lots of clever people thought, aha, wait a minute.
This discovery led to arguably the biggest breakthrough in genetic engineering yet, CRISPR. When it was announced to the world in 2012, it caused a huge frenzy and brought a lot of attention to its creator, a biochemist and professor at UC Berkeley.
Her name is Jennifer Doudna. And in academic circles, she's become a kind of rock star as co-creator of a scientific storm that's sweeping the whole world.
I describe it as surgery for the cell.
CRISPR stands for Clustered Regularly Interspaced Short Palindromic Repeats. It's a gene editing tool commonly described as genetic scissors because, in very simple terms, it can edit a DNA sequence with the same kind of ease and precision as editing a manuscript with a word processor.
It's sort of making precise changes to the code of life. It means that we can control human evolution now. We can control essentially anything that is alive. We can manipulate the script.
The implications were enormous, and Doudna and her colleagues were thrilled at the possibilities. CRISPR would have the potential to fix or replace missing genes and cure genetic diseases. But scarier possibilities began to enter Jennifer Doudna's subconscious. This is Hank Greeley, a law professor and director of the Stanford Center for Law and the Biosciences.
She had a dream in which a friend of hers brought a man to see her and asked her to explain CRISPR to this man. She thought the man was a little odd because he always kept his back toward her, but he was nodding. It seemed like he was understanding. And so she finished talking about CRISPR. He said it was very interesting, turned around, and he was Adolf Hitler. Although in her dream, he had a pig's nose. He had a pig snout, but he was Hitler with a pig snout. And she said she woke up in a cold sweat and decided that she really needed to pay more attention to these issues.
The dream was very prescient. In 2018, this story broke.
The Chinese researcher has created an international controversy over science and ethics after claiming he helped make the world's first genetically edited babies.
Twin girls whose DNA he says he altered with a powerful new tool that lets scientists edit the genetic code.
The scientist's name was He Jiankui. Some people call him JK. And he was beaming when he made the announcement on YouTube.
Two beautiful little Chinese girls named Lulu and Lala came crying into the world as healthy as any other babies.
Jiankui had gone ahead and done this, and he thought he was going to win the Nobel Prize and that everybody was going to applaud him and say how marvelous it was.
But this is not what happened at all.
That story of He Jiankui's genetic misadventures, if you want to call it that, that story, I think, was, in fact, the biggest medical story of the century so far.
There has been consensus that to take a embryo with altered genes and put it in a woman to create a child is just beyond the pale in terms of what's morally acceptable.
And that's what he says he's done.
That's exactly what he has said he's done.
By the time Lulu and Nana were born in 2018, concerns about genetically modifying human beings had been swirling around for decades. So what went wrong? Was there a clear line in the sand that He Jiankui crossed? And if so, why didn't anyone stop him from crossing it? As usual, the story is complicated, and it raises more questions than answers, including this one. Whose responsibility is it to make sure scientists act ethically? But before we can answer these questions, we need to go back to the beginning, before CRISPR was even in the toolbox. Chapter 1. CRISPR changed everything. Starting in the 1980s, scientists began to work out how to precisely edit DNA.
So in principle, the idea very quickly came up, okay, well, we could actually change one of those letters, make it right, and now, hey presto, somebody's been cured. So these ideas started to float about very quickly. And the initial method of doing this was using some enzymes rather exotically called zinc finger enzymes, which have got zinc in them, and I guess they look like fingers.
These enzymes would bind with a targeted sequence of DNA, and then other enzymes would slice the DNA.
Cells don't like having their DNA chopped up. It's not good for them, and they will try and fix it.
And as it tries to repair the DNA, it makes mistakes.
This is Kiran Musunuru, a cardiologist, expert in gene editing, and author of The CRISPR Generation.
And so you're wondering, well, how is that a good thing? Well, if you're trying to make a change, this is actually a good way to do it. So you can take advantage of the fact that the cell's trying to repair it, exploit that, and if you contrive things just right, you can actually get it to make the change that you want.
But it wasn't perfect.
The tool worked, but it didn't work very well at all, and it was very challenging to use.
In 2009, Musunuru switched from working with zinc fingers to something called talons.
They have a great name because they sound like things you can actually use to cut.
Talons worked well if you wanted to turn off a gene.
It's very easy to break things. Take a laptop computer. I can come up with many, many ways to break it, right? I can drop it on the floor. I can throw it against a wall. I can pour orange juice on it, right? And so the original gene editing tools were a lot like that. They were crude but effective.
But you don't always want to break things. Sometimes you want to fix things. And that's where CRISPR comes in. CRISPR enabled cutting and pasting DNA with precision.
What we saw is that the least efficient, the least effective CRISPR targeting in terms of making a change at a desired location in the genome was way better than the best, most effective example we had of talons going after any one of these locations. It wasn't even close. It was immediately clear that, wow, we're in a whole new world. Gene editing has just taken a huge leap forward.
This is a clip from an interview with Jennifer Doudna.
This is going to revolutionize human life. It's already beginning. It's going to mean that all of the genetic defects that have caused so much pain and suffering for people for millions of years, all of that could potentially be removed. So why does the great woman who invented this wake up in the middle of the night worrying about it?
When I started this research project, we were certainly not thinking about technology that would allow alteration of human evolution or anything of that nature. And over the last few years, I have gone from, wide-eyed excitement to realizing that there was real risk and that we really needed to be aware of this and discussing it. And one of the things that sort of brought that to the forefront of my mind was a dream that I had.
It was the dream about Hitler with the pig snout.
It sounds funny in a way to relate that image, but in the dream it was a terrifying thing, and I really felt real, just stone cold fear in the dream. And that was really one of the things that motivated me to get out of the lab and start talking to people more broadly about the technology, about its capabilities, about the great things about it, but also about things that really required really deep thought and careful consideration and regulation.
CRISPR is really accessible, and this is one of the things that makes it so scary. In theory, anyone can edit genes. So it begs the obvious question, will they all use CRISPR for good? And who defines what good is anyway? Plagued by questions like these, Jennifer Doudna assembled a small group of advisors and colleagues in Napa, California, in January of 2015. The group was just 18 people, and it included Hank Greeley, the Stanford law professor we heard from earlier. The Napa meeting only lasted a day, but everyone left with a homework assignment to help draft a document with recommendations on how to proceed. This is Hank Greeley.
So our consensus, which really emerged quickly during the meeting and was ultimately became an article published in Science a little later that year, it was not detailed. It was not intended to be specific guidelines, let alone regulations or legislation.
The document had some common sense recommendations. Create forums in which experts in bioethics can provide information and education. Encourage and support transparent research. Hank Greeley says the group was motivated to work quickly because of a rumor that was going around.
That somebody in China was about to publish something. I don't know who knew that. I don't know how early they knew that, but certainly the fact that people were moving forward, I think, added impetus for some people to really get this statement out.
Maybe it was fate. Maybe it was just a really good read of the room. Either way, it was the right move because that rumor was about to be proven true. Chapter 2. The first line in the sand is crossed. Just a month later, there was an announcement that made it clear that genetically modifying human embryos was not just a possibility, it was already happening. This is Françoise Baylis, a bioethicist and author of the book Altered Inheritance.
So in 2015, we had for the first time a scientist willing to publish an article in which he reported having made genetic modifications to human embryos. Up until this point, either people were doing it and hadn't reported it, or they weren't doing it, at least not in a human.
The scientist, Jianju Huang, was from China. Now, just to be clear, this is not He Jiankui, who we talked about earlier. He won't come into this story until a few years later in 2018. Jianju Huang used CRISPR to modify human embryos, but he didn't implant them into a uterus like He Jiankui would go on to do. The embryos he modified were non-viable. Still, this was alarming. No one had taken this step yet, and it was ethically controversial.
Because for the first time, this work, which had been done in non-human animals, was being done in a human.
Both Nature and Science rejected the article on ethical grounds, and it was published in a less prestigious journal, Protein and Cell. A big concern among scientists was spooking the public before it understood a key distinction in gene editing. There are two kinds of gene editing, somatic and germline. Somatic editing means changing the DNA of your somatic cells. hair, blood, skin, everything except your reproductive cells, aka your sperm or your eggs.
So making changes to your somatic cells doesn't have an impact on your progeny, on the next generation, on your children or their children. It means that if something goes terribly wrong, you haven't affected a whole lineage.
Germline editing does change the DNA of the reproductive cells.
So we're trying to make changes to the gametes, sperm and egg, or possibly the very early human embryo. And the goal there is to make sure that whatever genetic changes are made to those cells, they will in fact be passed on from generation to generation to generation.
When people have dreams about curing a single patient with a genetic disease, they're thinking of somatic editing. When they have nightmares about creating a race of genetically modified superhumans, they're most likely thinking about germline editing.
And it's in that context that people are really worried about the prospect of what could be opened up and how people might be tempted now to think not so much in terms of treatments, but perhaps in terms of enhancements. Now, I want to be clear, you could do enhancements with somatic genome editing and with heritable human genome editing, but the cultural imagination here is really stuck on this idea that we will build, super athletes or super armies or what have you. And so there's this idea that we would be going down a very risky path.
When the Protein and Cell article came out, some scientists who were developing somatic editing therapies for patients with genetic diseases wanted to distinguish themselves from anyone trying to do germline editing. And there was a clear message from them.
Don't edit the germline. So it's really clear. It's saying this is not research that should be done. And their worry is that if you go down this path, if you start manipulating the reproductive cells, if you're trying to have an impact on future generations, you're going to mess it up for us.
But there was also a more favorable view of germline editing.
The other commentary is a little bit more optimistic, shall we say. They're saying we ought to be able to go forward, but to do so, we need to be careful. And so they talk about a prudent pathway forward. So they are saying, look, it's a little premature to think that we would go down this path, but it's not inconceivable, and it's also not necessarily wrong. And a simple way to think about it is one and done. And so the idea there is, well, what is the point of having parents who are at risk of having children with a particular genetic disease reproduce, have children with that particular condition, and then have to treat those children? Why not eradicate it from that lineage? And so that's one kind of perspective that's put forward.
Remember this comment from a 1977 meeting on recombinant DNA?
And just because some scientists say that they don't want to create a new race of Superman, as Adolf Hitler did, doesn't mean that it's not going to happen.
It wasn't a theoretical, future ethical problem anymore. It seemed like the science had finally caught up to the fear. It was happening live and in color right now. That's why Jennifer Doudna wanted to do something about it. The gathering at Napa was the first step. Next, she tapped a group of 12 people, including Françoise Baylis, to organize the first international summit on human genome editing. 10 of the 12 were scientists. Françoise and one other person with a background in health law were the exceptions. The summit took place in December 2015. More than 500 scientists, journalists, ethicists, and patients gathered in Washington, D.C.
A statement, if you will, was made by the planning committee after that meeting. And by and large, it says, somatic genome editing, that's great. We know how to do clinical trials with gene therapies. Let's just go ahead and keep doing what we're doing. Let's advance that science.
They took a different stand on germline editing. They said it was okay as long as embryos were not implanted.
Moving on to clinical trials, transferring those genetically modified embryos into a woman, it's very clear that the committee says this should not be done until two conditions are met. So one condition, safety and efficacy.
This one seemed pretty straightforward. You don't want to harm anyone, and you want it to work. The second condition was broad societal consensus.
That is an extremely simple, and some might even say naive, ethics framework because it only has two elements. And typically, ethics frameworks have many, many more conditions, if you will, or criteria that have to be satisfied. But what I think is really wonderful about this framework, if you will, is that it's very simple, and yet it's also very complex.
Even the first condition, which is so basic, is more complicated than it sounds.
It's never going to be 100% safe. It's never going to be 100% effective. So somebody is going to have to make a decision about safe enough, effective enough. And that's where the values come in.
And then there's the second condition, broad societal consensus. It sounds like a worthy goal, but is it achievable?
If you're thinking about this on a global stage, we may never reach consensus. We may never get to that point of unity. But I maintain and I insist with a lot of confidence that we'll all be better off for having tried.
Better off, perhaps, but it still seems impossible. Matthew Cobb says it's because of a misconception about the scientific community.
I mean, this is a deceptive word because there is no community. This is the scientific community that suggests there's a group with common interests, there's a group with common techniques, but that's a trade, right? That's not community.
But the summit arrived at an agreement. They said they wanted a, quote, prudent path forward, to proceed with caution.
Amber light for your yellow light for gene editing, for embryo gene editing. In other words, yeah, okay, it could be good, just be careful, but go ahead.
Matthew Cobb was not particularly impressed.
It didn't get to the real issues. Why are you wanting to do this? What are you trying to cure? And that fundamental question, what is the point of this, was never actually addressed.
And that question would soon prove to be really important. Chapter 3. The First CRISPR Babies. In April of 2018, Marilyn Marchione was the chief medical writer for the Associated Press when she was tipped off by a source about an explosive story.
He mentioned that there was this possibility that a scientist in China had done germline gene editing. He said there might be a pregnancy underway, but no details. So I was a bit in limbo until I got more information.
It would be 4 months before she learned more. In August of 2018, a second source gave her the details the first one had left out. A Chinese scientist named He Jiankui claimed he had edited embryos using CRISPR. The edits were to make the embryos resistant to HIV. He Jiankui had implanted the embryos into a woman, and she was pregnant with twins. The father was HIV positive.
The very first question for us was this real or was it a hoax? When you claim to have done something totally unusual or totally extraordinary, you have a higher burden of proof because it is simply your claim. You need to produce corollary evidence. You need to show us science, scientific publications. You can't just make a wild claim, which is how this sounded initially.
In October, Marchione and her team went to Shenzhen, China, to interview He Jiankui. He agreed to talk to the Associated Press exclusively. Red flags appeared immediately. For one, the ethics panel that approved the experiment was from a different hospital than the one where the gene editing and implanting took place.
There were other questions about how he went about what he did that made us concerned, and the concerns deepened. He promised to publish animal research on embryo editing, and that never happened. So as we went along, we were getting more and more concerned about had this man actually done what he claimed.
When she returned home, Marchione got word that the twins had been born. He Jiankui said he would sequence their genomes and send his manuscript to a journal for publication. Marchione got the manuscript before it was published, and she had permission to share it with a scientist to verify that it was real.
I, as a layperson, couldn't look at these genetic sequences and say, oh, he did this or oh, he did that. It's very important that there be peer review of his work. So when I shared, and I insisted that we be able to do our own outside peer review, that we go to experts like Dr. Musunuru to look at the science and tell us what had happened.
Dr. Musunuru is the cardiologist and gene editing expert we heard from earlier. He agreed to look over the manuscript and keep the story a secret.
She finally sends it to me, and I see the headline, gene-edited twins, resistant to HIV, something along those lines, making it very, very clear that this was the result of embryo editing. And at that point, my jaw's dropping, and I'm getting very, very upset. Then I start looking through the manuscript, and I look at the data. And once I actually look at the pictures that are at the back of the manuscript, within milliseconds, I could tell it had went terribly wrong.
The pictures that Musunuru is talking about are chromatograms, essentially graphs that show DNA sequencing. They're visual representations of the DNA edits He Jiankui had done. And crucially, it was a way to see if his edits went as he intended them to go. You see, there are a few ways that gene editing can go wrong, but the two most common ones are off-target edits and mosaicism. Off-target edits have been described as collateral damage. Say you're making an edit somewhere in a manuscript, but as you go, you unintentionally make a new typo.
There's been a lot of realization that, this pair of scissors, in some circumstances, can look like a chainsaw gone amok, and you end up losing loads and loads of DNA sequences. If you're working in a mouse, it doesn't really matter, because you'll just get, the embryo will die and you'll get another mouse, and eventually you'll be able to make it work. If you're dealing with human beings, it's clearly rather a different kettle of fish.
Mosaicism is when the editing is inconsistent throughout all of the cells in the body. Imagine doing find and replace to fix a misspelled word, but only some of the words are corrected.
That's an issue where you start with one cell, single-cell embryo, you inject with CRISPR, that cell starts to divide in the dish very quickly, becomes 2 cells, then becomes 4 cells, then becomes 8 cells. The problem is CRISPR sticks around. It doesn't go away instantaneously. So you might have that initial cell, and maybe CRISPR hasn't done anything yet, then it splits into 2 cells. And now CRISPR makes an edit in one cell, but not the other cell. And then you have the cells divide even further and further. And what ends up happening is you have a patchwork where some cells have edits. Maybe they have the desired edit, the one that you want. Other cells have off-target edits or undesired edits. And then yet other cells may have no edit at all.
The chromatograms Musunuru was looking at showed the worst-case scenario. The twin girls had both off-target edits and mosaicism. The chainsaw had run amok.
Whatever He Jiankui thought was going on, it was horrible. And the fact that there were actually 2 live-born twin girls who had genomes that looked like what was in this paper, made me start crying and screaming in my office because I couldn't believe it, just the enormity of it, that someone is playing with human life so cheaply, so egregiously.
He Jiankui had already done embryonic sequencing before he implanted them. Theoretically, he should have been able to see that there were issues with the CRISPR editing then, yet he went ahead and implanted them. Why?
This is part of why I was screaming after I saw the data and yelling and crying and everything, is 2 equally bad possibilities. One, he knew exactly what the data meant. He saw the chromatograms and interpreted them properly. Didn't care. He was just such a horrible human being. It's like, I so badly want to be the first to do this and get all the fame and glory and maybe riches that I'm just going to go ahead and establish the pregnancy and, pass that milestone, even if it looks horrible from a scientific perspective. That's one possibility. And that's what I initially favored because I couldn't wrap my head around the second possibility, which is he's so incompetent that he's viewing these chromatograms and doesn't actually realize something is wrong. And maybe it's slightly less bad, but doing things out of ignorance or negligence is still very, very, very bad when you're dealing with human life, especially dealing with newborn babies. I called Marilyn and said, I'm absolutely 100% sure this is real. And that's because if this is fake, there's no way you could fake such terrible looking data. I tried later, just as sort of a thought. I tried in my laboratory. I said, let me try to fake these. I couldn't fake it. Like, it was the real deal. He had done it, and he had done it horribly wrong.
Musunuru gave an interview to the Associated Press, but the story was still under wraps, so he couldn't talk to anyone else about it.
She had sworn me to confidentiality, so I honored that. I didn't tell anyone, even though it was eating me up inside. And it was clear that he was going to make an announcement soon, but it wasn't clear how soon. And as each day goes by, I'm getting more and more anxious, not knowing ethically what am I supposed to do. There's human life involved here, right? And if somebody doesn't say anything, like, he could be establishing more pregnancies and be doing more of this. It was really eating at me. And people could tell that something was really, really bothering me, friends and family and whatnot. So it was not at all a pleasant time.
I remember having the shakes a lot when I worked on the story. It's truly a line in the sand. It's hard to say that you can imagine someone taking that step.
But someone did. And those fundamental questions that Matthew Cobb brought up loomed in the background. Why are you wanting to do this? What are you trying to cure? Chapter 4. The Unmet Medical Need. Right around this time, the second International Summit on Human Genome Editing was set to happen in Hong Kong from November 27th through the 29th. Marilyn Marchione made plans to go.
At the time that I booked my flight and made my plans to go to the conference, JK was not on the schedule. There were just other experts in the field, and I thought this is a perfect opportunity to find out if anyone knows that this has happened or been going on. By the time I went, he had been invited.
There's some real question whether he was going to unveil it to the world then, almost like an Apple/Steve Jobs type thing, talking about some, pretty mundane, fundamental scientific research, and then, pulling out the one more thing and saying, by the way, we've actually edited embryos. And by the way, we actually have these beautiful twin girls who have been born. That would have dropped you can imagine, a big rock, in the ocean, bam. That would have gotten so much attention.
By the time I landed Sunday night in Hong Kong, I went to the hotel, went to sleep, I woke up, but another story had been published detailing a posting that JK had made.
A headline in the MIT Technology Review read, "Exclusive. Chinese scientists are creating CRISPR babies." Marchione had been scooped.
So JK had published something that put some of this in the public domain. And at that point, it's out there. All bets are off.
The story revealed what Marchione already knew, that He Jiankui and his team had been using CRISPR to edit embryos to disable the CCR5 gene.
What he was trying to do was to alter a gene which is associated with resistance to HIV. It doesn't mean you are immune to HIV, but it means you're less likely to catch it.
The article was published on November 25th. By the time everyone got to Hong Kong, they all knew about the story.
Whatever had been planned, the buzz is all about what's happened. Who did this? Are these children alive? Are they well? Is anyone else doing this? So it really takes over the conversation, and this is before the meeting gets started.
A day after the MIT Technology Review story came out, the Associated Press hit publish on Marilyn Marchione's story.
It wasn't a race to publication. I know that some people view it that way. I felt as if we had a great deal more information about this case, including that the sort of flaws in the science that supposedly the ethics panel that had approved this experiment was not even the hospitals where the work was done. There were many, many questions about what he had done and how he had gone about it. So we had a much more complete accounting and more detail to bring to the table and to share with the public at that point. And I'm really proud of that work. Thousands and thousands of words, tens of thousands of words at this point, not a single correction. Our report has stood the test of time.
At this point, the public was aware of He Jiankui's claims that there were 7 couples who went through embryo editing and IVF, and one of the pregnancies had resulted in the birth of twins. They were referred to as Lulu and Nana, but these are not their real names, and no one knew the identity of the parents. Marilyn Marchione never even met them. The story set off a frenzy among scientists and ethics watchdogs. In Hong Kong, there was a frenzy in the audience before He Jiankui even went on stage.
So just to remind everyone here that we want to give Dr. He a chance to explain what he's done. So please, can you allow him to speak without interruptions? As I said, I have the right to just cancel the session if there's too much noise and interruption.
Okay, thank you. First, I must apologize that these results leaked unexpectedly, taken away from the community of the full data being presented immediately in a scientific venue.
He Jiankui quickly addressed his reason for choosing the CCR5 gene.
So HIV remains a top 10 cause of death in several countries, in particular developing countries. This is a serious unmet need, as an infection's severity is often made even worse by discrimination.
And he shared his pride in the experiment, speaking specifically about the twins' father, who was HIV positive.
He lost the hope for the life. But when the baby was born and with his protection, he sent a message at the day of birth, saying, I will work hard, earn money, and take care of his 2 daughters and his wife for his sacred heart.
There were 500 people at the summit, and nearly 2 million more were watching on the live stream. Matthew Cobb was one of them.
I remember watching this on the live stream and on Twitter when it was good, because you got people who knew what they were talking about watching the live stream and then hammering out tweets describing what was happening. It became immediately very, very obvious that something had gone horribly wrong.
What blows my mind is that he shows the same data that are in the manuscript, the chromatograms, that to me look absolutely horrible, which made me think, wow, he has no clue that this is making him look so horrible on so many levels. Negligent, incompetent, just monstrous behavior as a human being.
After He Jiankui's presentation, the questions poured in.
How are you going to prove the effectiveness of the treatment if the 2 individuals remain secret?
He Jiankui responded that it was against Chinese law to disclose the identity of HIV-positive people in public. Other questions were about informed consent.
How did you convince the parents when you started this experiment? Did you tell them there's alternative solutions, for example, other ways to avoid of AIDS infection of their child?
And David Liu of Harvard, he asks the most important question.
So could you first describe what is the unmet medical need, not of HIV in general, which I think we all appreciate, but what is the unmet medical need for these patients in particular? And second,
what was the unmet clinical need? And He Jiankui hasn't got an answer. But, before you do any biomedical intervention, you have to be sure this is the best thing for that patient. But these weren't patients. These were 2 normal, well, they were going to be 2 normal girls. Their embryos, their DNA was as normal as anybody else's, right? And now they've been mutated. So there was no clinical need. They had none. If they didn't want to get HIV when they're older, well, that's relatively easy to do. As I say to my students, you all know how not to get HIV. It's not rocket science. It doesn't involve editing your genes. There are very simple ways of not getting HIV. So his starting point was extremely odd, right?
He Jiankui claimed that because the father of the girls was HIV positive, This was a way to make sure his children didn't have it. But just because you're HIV positive doesn't mean that your offspring will be. And beyond that, the fact is that there are other treatment options for HIV.
It's not a death sentence like it was in the 1980s. And so it's really hard to make an argument that, wow, by turning off this gene and making people more resistant to infection with HIV, that we're filling a desperate medical need here. Because the fact of the matter is, you're not. So why on earth do you need to mess with embryos? It's just so disproportionate. The potential for benefit is so low and the risks are so high.
He Jiankui didn't have any satisfying answers to these big questions. It seemed like he hadn't even seen them coming. He was convinced, and was trying to convince others, that this edit had been medically necessary. But it actually seemed more like an enhancement, something dangerously close to that 1977 fear of creating a race of supermen. Here's Hank Greeley again.
He thought he was going to be welcomed as a revolutionary scientist, and he was shocked to discover he hadn't become famous, he had become infamous. He clearly hadn't thought this through, and ultimately he got angry and kind of stomped off. And that was the last time anybody saw him in public for nearly 4 years.
Chapter 5. Piecing Together What Happened. After the summit, scientists and the media started to scrutinize what had happened. One of the most alarming things about the experiment was the process of getting informed consent.
It breaks every ethical principle of medical research to do things in the way that he did. If you look at the quote-unquote informed consent document that He Jiankui prepared for the patients in his quote-unquote clinical trial, it reads more like a contract. And there's language in there that basically exonerates He Jiankui and his team from any bad thing that happens. That is not what an informed consent document ever is supposed to say. So this was a mockery of a clinical trial.
Then there was how he recruited the patients. In China, it's illegal for people with HIV to get IVF. So, under normal circumstances, it wouldn't have been an option for Lulu and Nana's parents because of the father's HIV status.
So here, He Jiankui was offering, hey, sign up for this clinical trial, and it's kind of a loophole. You can actually have kids after all. The only thing you have to do is let me work on those embryos and edit these embryos. But you know what? That's even better because not only will you get to have kids, you'll have kids who are immune to HIV. So that's how he sold this bill of goods.
To Marchione, it seemed like the parents were just trying to have a kid any way they could. They weren't in it for the gene editing.
It would be like if you were a prisoner and they offered you food and you'd been starving.
Under informed consent rules in the U.S., participants would be permitted to leave any time for any reason. This agreement was different.
It says, if you withdraw from the trial, you owe us money. You have to pay back all the health care. You potentially have to pay back a penalty, a monetary penalty that's much higher than the average annual income of a citizen of China.
The consent forms also concern themselves with things that I've never seen before in scientific documents, like you must agree to photographs with me, the researcher, and you must agree to, this kind of publicity.
But the issues went beyond just informed consent. In fact, if we go all the way back to the beginning, there was a big question that needs an answer. Was He Jiankui the best person to do an experiment like this? In the practice of editing DNA, specificity matters, and He Jiankui is not a geneticist. He's a biophysicist.
Under no circumstance would you consider him appropriate to not a physician, no experience with clinical trials, not even a very good scientist, taking it upon himself to run a quote-unquote clinical trial.
Still, the story in the scientific community was that He Jiankui was a lone bad actor. But we talk a lot about the collaborative nature of science. Those summits and conferences and meetings are all a demonstration of that. And so, in addition to the issues with informed consent and He Jiankui's scientific background, is also the question of how alone one scientist can truly be. Here's Françoise Baylis.
Jiankui was not a rogue scientist. He did exactly what a scientist is trained to do, which is to be ahead of the pack and to be bold and to make those innovative moves, to be the first. I mean, that's how you get a Nobel Prize. You don't get a Nobel Prize for following the pack.
He Jiankui had studied in the United States at Rice University and Stanford, and he told several well-known geneticists from these institutions what he was planning on doing. And while they disapproved of it, no one tried to stop him. So didn't they have a responsibility to warn someone?
There's no police you can, inform, like, hey, there's this bad stuff going on in China and someone might be, establishing pregnancies with edited embryos. You should, go do something about it, right?
Here's Françoise Baylis again.
You don't get to walk away by saying I didn't have a number to call. And the reason I say that is all you had to do is pick up the phone and call any major newspaper. It was a scoop. It was a story. Do you really believe that no newspaper would have wanted to investigate this and to have been first to say this is happening? So there were options.
We don't know why these scientists chose not to say anything when they had the chance. Baylis says that perhaps it's worth questioning scientific norms.
We need to look at the way in which we do science, the things that are normalized in terms of science. And so one of the things is you don't rat out your colleague, And, there are some scientists around this particular case who have said, this was told to me in confidence, and therefore I'm going to respect that confidence, and it's not up to me to tell the world what he's doing. Well, why is that the norm?
And what about the scientific community as a whole? Don't they bear some of the responsibility? Matthew Cobb says the gatherings at Napa and Washington, D.C. missed the boat on the safety issue.
They just kind of assumed, it's a pair of scissors, right? What harm can you do with a pair of scissors? Well, you don't want to have a crazy person in your house with a pair of scissors. They can do a lot of harm.
Musunuru thinks scientists at those meetings should have taken a firmer stand against germline editing.
I think that would have been more effective if they had unilaterally said, look, we do not know what we're doing. We do not understand the safety risks. There should be a moratorium for an indefinite amount of time until we get a better grasp on things. They did not do that. At either of these international summits, they were much more equivocal in their language and saying, well, maybe this might be useful. Maybe there's a path forward. We don't think it's there yet, but maybe there's this checklist of things, and if you check off enough things, then you can go forward. And that was the wrong move because, at least the way he tells it, He Jiankui took that checklist and said, oh, I think I've checked off everything, so I think I'm fine.
Françoise Baylis says that this episode should serve as a lesson for scientists.
I think it's really important for the scientific community as a whole to take responsibility and to think about the ways in which it keeps advocating for self-governance. We can take care of this. We know how to police ourselves. And yet at the same time, you have these kinds of failures. Now you can, and people have, just pointed to the one case, that one bad apple. But I think we really ought to look at the container, the bushel. What's the bushel holding both these good and bad apples?
One year after the Hong Kong summit, this story broke.
So a Chinese scientist helped create the world's first genetically edited babies. He is going to jail. His name is He Jiankui of China. He is going to be in prison for 3 years for carrying out what the Chinese government says were illegal medical practices. So last November,
the Chinese government was clearly not interested in examining the bushel. They went for the one specific bad apple. He Jiankui was charged with practicing medicine illegally and violating scientific regulations and norms. He was in prison for 3 years. But recently, he started making news again.
I started noticing a lot of his posts going viral.
This is Saiwei Chen, the China reporter for the MIT Technology Review.
And it's usually one quote, like one very, I would say provocative and controversial, almost rage-baiting statement. Sometimes it's just nonsensical and very crass, but the other times it is straight up offensive or provocative.
Here are some of his posts, which are often accompanied by a picture of him staring into the camera or off into the distance. Pursuing forbidden knowledge is innovation. Great revolution begins with controversy. Ethics is holding back scientific innovation and progress. In another, he says, if I had to do it all over again, I would do exactly the same thing. They're so surreal that they seem like a parody or fake. But Chen confirmed that they were, in fact, him, and they were very real.
I think we emailed him at the time, and he admitted that it was him.
The concerning part is that he's getting the attention he is so clearly seeking.
Do you think you're noticing a real and emerging phenomenon, which is like there is an appetite for this type of like boundary pushing, to put it in a nice way? There are a lot of alternative thinkers and this like niche market, at least curious or interested in designer babies.
Which makes other scientists really worried that He Jiankui is more emboldened than ever, that he might try it again, if he hasn't already. Some also worry that CRISPR's reputation has been tarnished. Kiran Musunuru has worked hard against that narrative. For weeks after the articles were published in 2018, he gave interviews, sharing what he knew and hammering this message.
It's not all bad. This doesn't condemn CRISPR. The concern was that legislators, for example, would say, oh, CRISPR's bad, like, this is horrible. We're just going to ban the use of CRISPR for any sort of medical applications altogether. To their credit, legislators did not do it. They seemed to understand that there was some nuance there.
And that's a good thing for all of us, and Musunuru in particular, because he was about to have one of the biggest CRISPR breakthroughs yet.
In this morning's Health Watch, a historical medical breakthrough. A baby named KJ, born with a rare genetic disorder, is the first person in the world to be successfully treated with a tailor-made gene therapy. The baby's family
Musunuru developed the treatment for baby KJ, which, to be clear, was somatic gene editing to meet an otherwise unmet medical need. As someone who's seen all sides of what CRISPR can do, Kiran Musunuru has done some reflecting.
The lesson that I've taken out of this is that, you can be as noble as you want and really try so hard to persuade your peers that this is the right way to do things. And maybe even mobilize a lot of them and start to talk about self-regulation and we need moratoriums or we need to do things in a thoughtful, careful, rigorous way. But it isn't that effective. There's no guarantee that's going to be effective. The better way to do it, honestly, is legislation and regulation.
Distillations podcast is produced by the Science History Institute and recorded in the Lori J. Landau Digital Production Studios. Our executive producer is Mariel Carr. Our producer is Rigoberto Hernandez. Our associate producer is Sarah Kaplan. And our sound designer is Samia Bouzid. This episode was reported and produced by Mariel Carr and Rigoberto Hernandez. Support for Distillations has been provided by the Middleton Foundation and the Wincote Foundation. You can find all of our podcasts as well as our videos and articles on our website at sciencehistory.org. And you can follow us on social media at SciHistory.org for news about our podcast and everything else going on in our free museum and library. For Distillations, I'm Alexis Pedrick. Thanks for listening.